Good morning, 7th graders. Today we are in lesson 12. We are using prime factors to reduce fractions. So far when you work with fractions, you usually just find in your head your greatest common factor and then you divide your numerator and your denominator by that greatest common factor to reduce our fraction. Today we're learning about using prime factors to reduce our fractions, and we're using our upside down division to do that. Do you guys remember how to do upside down division? Excellent. Let's start reading at the top of page 50. It says, to reduce a fraction to its simplest form, we divide both terms by a common factor, usually the largest common factor we can identify. Sometimes we have to divide several times before the fraction is in its simplest form. So you guys remember doing that? Sometimes we would reduce our fraction by our greatest common factor, then we have to reduce it again and again until it was finally in simplest form. If the fraction is small, this is not too difficult. So it's pretty easy if we have, let's just say, if we would have this number right here, 10 over 20 as a fraction. We could reduce that very quickly to 1/2, right? Because we know that 10 is our common factor for both of those. But what if we have a fraction like this? It's pretty big, right? Might take a little more to just do that in our head. So, however the larger the terms of the fraction, the more likely we are to miss a common factor when reducing. So if we have a large fraction like this, it might be kind of likely that we miss a factor when we're reducing it, okay? If we use the prime factorization to cancel out the greatest common factor of both terms, we can quickly find the simplest form of the fraction by multiplying the remaining prime factors. Study the example. All right? So what we're learning today is how we can use prime factorization to find our simplest form of larger fractions like this. So you guys remember when we used our upside down division to find our prime factors? So we could just start here and we could just go here. We have 3, we have 2, 1, 3, and 7. All right, so these are our prime factors for our top numbers. So we have 2 times 3 times 3 times 7, right? That's our number for our 126. Those are our prime factors, all right? So then let's find our prime factors for 144. So then we have 2, and then we have 72, we have 2, we have 36, 2, we have 13, 2, we have 9, 3, and 3. All right, so we have 1, 2, 3, 4. 4, and we are not going to write these with exponents, okay? Because we have to be able to cancel out where we can then with our prime factors. So we have that. All right, so we just did step 1. Now notice what step 2 is. It says cancel out the common primes. So notice we could cancel out this set of 2. We could cancel out those and those. And what are we left with? If we notice, we're left with 2 2s on our bottom, or 3 2s, and we're left with a 7 on top. So right with left, step number 3, and then number 4, multiply and write the reduced fraction. So we have nothing to multiply on top, so we simply have 7. 2 times 2 is 4, times 2 would be 8. So we have just reduced that fraction down to 7/8. All right? Let's keep reading. This is the same as dividing the original factor by its greatest common factor, which would have been 18, or the numbers we canceled out, all right? So the numbers we canceled out would have been our greatest common factor if we would have multiplied those all together. And so notice if we would have went 126 divided by 18, we would have came up with 7. If we would have went 144 divided by 18, we would have came up with 8, all right? Moving on, it says, but instead of finding the greatest common factor and dividing each term by 18 to reduce the fraction, it is easier to just cancel out the greatest common factor and use the remaining factors to find the simplest form of the fraction. All right, let's move on to the last part of page 50, it says sometimes you may cancel out all the prime factors in our numerator. So it's our top number, remember? In that case, make the numerator of the reduced fraction 1. And here's why. So if you guys are familiar with canceling out fractions or canceling out our denominator and our numerators. So if we cancel this out, it's the same thing as putting a 1 here, right? We put a 1 if we were multiplying fractions and we were canceling them out, we put a 1 there. Same thing here, we put a 1 here, and we put a 1 here, a 1 here, and a 1 here, right? So then we would just be multiplying all those 1s on the top together, which is going to equal 1, right? And then on the bottom, we're going to just have 2 times 2, which we have just reduced then 108 over 432 to 1/4, all right? So if you're doing any of those on the next page, your new part numbers 1 through 5, and go ahead and do all of them, even number 5, the star problem. If you come across one where you've canceled out all your numerators on the top, just go ahead and make it 1, because that's why. If we cancel it all out, it's like there's a understood 1 up there. All right, I'm going to let you guys go, and that's your new part for today's lesson. You guys have 2 more, 8 and 9 are star problems on 51. You guys may skip those on the bottom of page 51. And you have another star problem in number 18. You can go ahead and do that one. That one looks like a lot of fun. You get to write a number in scientific notation, a big one. And that is all for your lesson today, and I will see you guys later. Hope you have a great day.